Welcome to Tunur online classes. In previous videos, we have already discussed about how to measure the length, how to measure the mass, and how to measure the time. So in this video, we are going to discuss a new topic. So that is the dimensions. It is very important topic in this chapter. That is the dimensions. Okay. So then, what do you mean by this dimension? So the meaning of this dimension is the dimensions of the physical quantity, the power to which the fundamental quantities are raised to represent the physical quantity. Right? So the definition of dimensions is the dimensions of the physical quantity, the power to which the fundamental quantities are raised to represent the physical quantity. So then, what is the meaning of this definition? What is the meaning of this definition? So here, any physical quantity which can be expressed in terms of the powers of the fundamental physical quantity. So that is known as the dimensions. Okay, see. Example. So here, length is a one physical quantity. Mass is a one physical quantity. Time is also a physical quantity. Right. So here, these physical quantities are expressed in terms of the powers of the fundamental physical quantity. So that is known as the dimension. So first example is length, right? So length, the dimension formula for this length is, it is denoted by capital M. It is denoted by capital M, or M to the power is 0, L to the power is 1, T to the power is 0. So this is also dimension formula for length, right? So here this is also right and this is also right. So here length means it's having only length. That means that is L. So the dimension formula for length is L, and the one more form is M to the power is 0, L, T to the power is 0. So this is also the dimension formula of length. So next one is mass. So the dimension formula for mass is, that is capital M. Dimension formula for mass is, that is capital M. So or this is M to the power is 1, L to the power is 0, T to the power is 0. Right? And the next one is the time. The next one is the time. It is denoted by capital T. The dimension formula for time is T, or M to the power is 0, L to the power is 0, and T. So this is the dimension formula for time. So most commonly, we are expressing the dimension formula in terms of its fundamental quantities. So the maximum we are used, so that is mass, length, time, and electric current. Electric current dimension formula, that is A or I. A or I. After that, temperature. The dimension formula for temperature is Kelvin. Okay. The list of some physical quantities. The first one, the serial number, and second physical quantity, and the dimensional formula. The first one is length. The dimensional formula for length, it is denoted by L. Close bracket, that is L. And the second one, mass. Mass, it is denoted by capital M. And third one is time. Third one is time. It is denoted by capital T. And fourth one is temperature. Fourth one is temperature. The dimension formula for temperature is Kelvin. It is denoted by capital T. It is denoted by capital T. So fifth one, electric current. Electric current. The dimension formula for electric current, and sometimes we are using capital A or capital I. In some cases we are using A, in some cases we are using I. Right? That is the dimension formula for electric current, that is capital A or capital I. And the sixth one is luminous intensity. Luminous intensity. So luminous intensity, so the dimension formula for luminous intensity is candela C, and the seventh one is amount of substance. Amount of substance. The dimension formula for amount of substance is mole. So these are the fundamental physical quantities, and it's the dimension formula. So here the dimensions means all the physical quantity, it is expressed in terms of this power of this fundamental physical quantity. So in this case, in the first three terms, length, mass, time, in that case we are using the dimension formula is, that is L, M and T, and the remaining four quantities we are using the SI unit of this physical quantities. Okay. So here the first three is the dimension formula for these physical quantities, that is L, M, T, and the remaining four physical quantity dimension formula is, in this case we are using the SI unit of this, then the SI unit of this physical quantities. So these are the fundamental physical quantity and its dimensional formula. With the help of this fundamental physical quantity, next we will write other physical quantities dimensional formula. The first one is length. So already we know that the dimension of length is, that is L. It is also written as m to the power is 0. M to the power is 0, L to the power is 1, and T to the power is also 0. So this is the first example. And the second example is, so here we want to write the dimensional formula of area, right? If you know the formula of area, we can easily write the dimension formula for that physical quantity. Here area, so then how to find the area? What is the formula to calculate the area? So here already we know that area is equal to length into breadth. Length into breadth. So here length is L indicates that length, and B is also breadth, means the dimension formula of this one is, so this is also L and this is also L. The dimension formula for area is L square. The dimension formula of area is L square, because so length into breadth, the dimensions of a length is also capital L, and the dimension of breadth is also capital L. L into L is L square. And similarly, the third one, volume. And how can we write the dimension formula for volume? So already we know the formula to calculate the volume is, that is length into breadth into height. So already we know that the dimension formula of area is, that is L square. So here the length, the dimension formula is L, the breadth is also length, this dimension formula is also L, and height is also L. So then dimension formula of volume is L square. The dimension formula of this volume is L cube, right? So this is L. The dimension formula of volume is L cube. And the next one, velocity. The next physical quantity is velocity. If you know the formula to calculate the velocity, means you can easily write the dimension formula for velocity. So velocity means as a displacement by time. Velocity means displacement by time. So then what do you mean by this displacement? So displacement means the shortest distance between 2 points. The shortest distance between 2 points, so that is known as the displacement. So then velocity, that is equal to displacement by time. The velocity is equal to displacement by time. So the displacement dimension formula is, that is capital L. The displacement dimension formula is L, and the dimension formula of time is, that is T. So then the dimension formula for velocity is L t to the power is minus 1. L t to the power is minus 1, or m to the power is 0. L t to the power is minus 1. So this formula to calculate acceleration is velocity by time. Velocity by time. So here, velocity dimension formula is, that is L t to the power is minus 1 or m to the power is 0, L t to the power is minus 1. So here, the dimension formula for velocity is L t to the power is minus 1 divided by the time is divided by capital T. So then, dimension formula for acceleration is L t to the power is minus 2. L t to the power is minus 2. So this is the dimension formula for acceleration. The next one, force, right? The next one is force. So here we are going to write the dimension formula for force. So to write the dimension formula for force, first we have to know what is the formula to calculate the force. So already we know that according to the Newton's second law, the force is equal to mE. Force is equal to mE. So then what do you mean by m here? M is nothing but mass. A indicates that acceleration. So then what is the dimension formula for mass? The dimension formula for mass is, that is capital M. And what is the dimension formula for acceleration? The acceleration dimension formula is L t to the power is minus 2. Okay, with the help of these two, we are going to write what is the dimension formula for force. The dimension formula for mass is, it is denoted by capital M. And the dimension formula for acceleration is L t to the power is minus 2. L t to the power is minus 2. So then, dimension formula for force is L t to the power is minus 2. So this is the dimensional formula for force. Next one. Okay, next example. So this force is completed. Next one is energy, right? So in this case, we are consider potential energy. The expression to calculate the potential energy is, that is mass into acceleration due to gravity into height, right? So this is the formula of energy. Potential is equal to mgh. So then here we want to write what is the dimension formula of potential energy. Okay, see here the first term is mass. The dimension formula for mass is denoted by capital M, and acceleration due to gravity. The acceleration due to gravity, its dimension formula is also similar to the acceleration, that is L t to the power is minus 2. And here h is nothing but displacement. Displacement dimension formula is, displacement is nothing but length, then its dimension formula is L. So then we will write the dimension formula for energy. The first one is mass, it is denoted by capital M. So M. Next, acceleration due to gravity, G indicates that acceleration due to gravity. The dimension formula for acceleration due to gravity and acceleration both are same. So here is the dimension formula for mass. Next, acceleration due to gravity, dimension formula is L t to the power is minus 2, and height is nothing but displacement. The dimension formula for height is, that is L. So then dimension formula for energy is, that is M as it is. Next, L into L is L square, t to the power is minus 2. So this is the dimension formula for energy. Potential energy dimension formula is M L square t to the power is minus 2. So next, another example, eighth example. So that is kinetic energy. Kinetic energy is equal to 1 by 2 m into v square. So already we know that the expression to calculate the kinetic energy is 1 by 2 m into v square. So here, compared to previous example, so this expression is little bit different. So in this case, it involving a constant term. So 1 by 2 is the constant term. In this case, we are neglecting that constant term while writing the dimensional formula. So after that, here is also M indicates that mass, V indicates that velocity. So mass dimension formula is, that is M, and velocity dimension formula is, that is L t to the power is minus 1. So then dimension formula for kinetic energy is mass is represented by capital M and velocity is represented by L t to the power is minus 1 whole square. Right? So then dimension formula is M L square t to the power is minus 2. The kinetic energy dimension formula is M L square t to the power is minus 2. Here one observation is there. So that is potential energy and kinetic energy, both the dimension formula is the same. Both the dimension formula is same. That is also M square t to the power is minus 2. Here is also its dimension formula is M square t to the power is minus 2. If a physical quantity having the same SI unit means it's having the same dimensional formula. For example, the SI unit of potential energy is also joule. The SI unit of potential energy is joule. It is denoted by J. And here is also the SI unit of kinetic energy is also joule. If a physical quantity having the same SI unit, it's having the same dimensional formula. It's having the same dimensional formula. Okay. The last one is gravitational force. To calculate the gravitational force, we have already one expression, that is F is equal to m1 into m2 divided by r square. Right? So with the help of this formula, we are going to find out what is the force of attraction between the two planets. The formula is F is equal to g into m1 into m2 divided by r square. F indicates that force, capital G indicates that gravitational constant, m1 and m2 indicates that the mass of first planet and mass of second planet, and r indicates that the distance between the planets. So here we are going to write what is the dimensional formula for capital G. Right? So the dimensional formula for capital G. Capital G indicates that universal gravitational constant. So then capital G is equal to F into r square divided by m1 into m2. So this is the expression to calculate the G value. So then in this case we are going to write what is the dimension formula for capital G. Right? So capital G is equal to, here this is a force, F indicates the force, R indicates the distance, m1, m2 are the masses. So then what is the dimension formula for force? So this is the dimension formula for force. The dimension formula for force is m L t to the power is minus 2. M L t to the power is minus 2. And R is nothing but distance. So distance, the dimension formula for distance is, that is L. So this is L square divided by m1 and m2 are the masses. These are the masses means the dimension formula for mass is capital M into M. That is m square, or capital M into capital M. So then this is equal to m L t to the power minus 2 L square divided by m square. M L t to the power is minus 2. This is L square divided by m square. So then dimension formula for G, that is equal to, so this is in the form of a to the power is n divided by a to the power is n, that is equal to a to the power is n minus n. Right? Okay, see. So this is m to the power is 1 and this is m to the power is 2. So then the m to the power is minus 1. Next, this is l to the power is 1 and this is L square. So this is the form of a to the power is n into a to the power is n, then a to the power is n plus n. So this is l to the power is 1 and this is l to the power is 2. So then it's become l to the power is 1 into l to the power is 2, that is equal to L cube. Right? So l to the power is minus 1 L cube t to the power is minus 2. So this is the dimension formula of G. So this method we are used to find out the dimension formula for constant terms. Okay, the next topic is what are the applications of dimensions? What are the applications of dimensions. These applications are very, very important. The first application is to convert one system of unit to another system of unit. Right? The first application is to convert one system of unit to another system of unit. And the second application is to check the correctness. To check the correctness of the given equation. And the third one is to connect the relation between various physical quantities. So these are the applications of a dimension. The first one is to convert one system of unit to another system of unit, and the second one is to check the correctness of a given equation, and the third one is to connect the relation between various physical quantities. So in that one, first we will discuss about the first application, to convert one system of unit to another system of unit. So then what do you mean by this one system of unit to another system of unit? So already we know that the system of units, so there are four types. One is the CCS system, FPS system, MKS system, and SI system, right? So here, with the help of this application, we are converting one system of unit to another system of unit. For example, SI system to CCS system. Okay. So first we see the general expression. So already we know that to represent a physical quantity we require two terms. One is the numerical value and one more is the unit. Right? So here we are going to convert this physical quantity from one system of unit to another system of unit. You can see it. So in the first system of unit, that is x is equal to n1. Unit can be expressed in terms of dimension. So then this value is m1 to the power is a, l1 to the power is b, and t1 to the power is c. So this is the applications of dimension. So we write the unit in terms of its dimensions. So in first system of unit, the physical quantity can be represented as x is equal to n1 to the power is a, l1 to the power is b, and t1 to the power is c. Next, the same physical quantity we measure in another unit or in second unit. In second system of unit. So in that case, x is equal to m2 bracket m2 to the power is a, m2 to the power is b, t2 to the power is c. Right? So the same physical quantity can be measured in two different units. In first unit, its physical quantity value is, that is n1, m1 to the power a, l1 to the power is b, t1 to the power is c. So this is our first expression. And in fact, the same physical quantity is measured in another system of unit or second system of unit. In that case, its value is m2 to the power is a, m2 to the power is b, t2 to the power is c. Right? So from these two equations, equation number 1 is equal to equation number 2. The left side of the both equation is same, then we are equating equation number 1 and equation number 2. Equation number 1 value is n1 bracket of m1 to the power is a, l1 to the power is b, and t1 to the power is that is equal to l2, m2 to the power is a, l2 to the power is b, and t2 to the power is c. Right? So this is the general expression. So here we want to calculate what is the n2 value. So then n2 is equal to n1 as it is. So next m1 divided by m2 to the power is a, l1 divided by l2 to the power is b. Next t1 by t2 to the power is c. So this is the expression we are used to convert one system of unit to another system of unit. If we know the n1 value, we can easily convert one system of unit to the another system of unit. Okay, this is the first application. First, we are considering the x is a physical quantity. It can be represented into numerical value and the unit. So this same physical quantity we have measured the two different units, right? In the first unit, the value of this physical quantity is this one, and the same physical quantity is measured in another unit. Its value is this one. So here, LHS side of the both equations are same. Then you are equating the equation. Equating these two equations, you get the general form. After that, simplify this expression. So then n2 is equal to n1 bracket of m1 by m2 to the power is a, l1 by l2 to the power is b, t1 by t2 to the power is c. This is the general expression to convert one system to another system of unit. Okay. Let's see the example. The first example is convert 10 joule into erg. Convert 10 joule into erg. Okay, see here. So 10 joule. So joule is the SI unit of energy. SI unit of energy. Next, erg is the Celsius unit of energy. Celsius unit of the energy. So here we are going to convert SI system. Here we are going to convert SI system to Celsius system. Okay. So already we know the general expression. N2 is equal to N1 bracket of M1 by M2 to the power is A. Then L1 by L2 to the power is B. T1 by T2 to the power is C. So then we are going to find out what is the M1 M2 value, L1 L2 value, and T1 T2 value. Okay, see here. So here this is the 10 term, it denotes that the N1 value. So here N1 is equal to 10. N1 is equal to 10. So then this is the SI unit of energy means in this case we have to write the dimension formula for energy. Dimension formula for energy. The dimension formula is already we know that it is m L square T to the power is minus 2. Dimension formula for energy is m L square T to the power is minus 2. So then we are going to find out what is the m1 m2 value and L1 L2 value. So here the first one in SI system and the second one is CGS system. CGS system. In SI system, mass can be measured in terms of kg. That is M1 is equal to 1 kg. Next length can be measured. L1 is equal to 1 meter. And time can be measured. That is 1 second. Similarly, in CGS system, mass M2 is equal to mass is measured in terms of gram. That is 1 gram. Length is measured in terms of centimeter. That is 1 centimeter. Time T2 measured in terms of second. That is 1 second. Right? So these are the values. Right? M1, L1, T1 values and M2, L2, T2 value. And already they are given N1 value. So here we want to calculate what is the N2 value. So what is the N2 value? So already we know the expression N2 is equal to N1, M1 by M2 to the power is A, L1 by M2 to the power is B, T1 by T2 to the power is C. So in this expression already we know that N1 value is known, M1 by M2 value is also known, L1 by L2 value is also known, T1 by T2 value is also known. Next we are going to find out what is the A value, what is the B value and what is the C value. So here just we are comparing the power of this fundamental physical quantity to the power of the dimension formula for energy. So here the power of mass is 1. The power of mass is 1 and the power of mass is A. So from this one A value is equal to 1. A is equal to 1. Similarly, the power of length is 2 and here the power of length is B. Then B is equal to, then the value of B is equal to, that is 2. Similarly, so here t to the power is minus 2 and here t to the power is C. Then C is equal to minus 2. Then C is equal to minus 2. So next we are substituting these all the values in that expression. Okay. So now we are substituting all the values in that expression. So here N2 is equal to as it is N1 value. So N1 value is 10. Substitute here. Next M1 value is 1 kg. Next M2 value is 1 gram. Our A value is that is 1. Next L1 value is that is 1 meter. L2 value is 1 centimeter. Power is B value is that is 2. Similarly, T1 value in SI system is also 1 second. In CSI system is also 1 second. Right? The C value is that is minus 2. C value is minus 2. So these two terms are get cancelled. So next step. So this is done as it is. So here we are converting SI system to CGS system. So then 1 kg is equal to 1000 gram. 1 kg is equal to 1000 gram divided by gram. So the power is 1. Right? So here we are converting 1 meter to centimeter scale. So that means SI system to CGS system. So that is 1 meter is equal to 100 centimeter divided by centimeter. Right? So the power is that is 2. So in this case, gram get cancelled, centimeter get cancelled. So then this is 10. It can be written as 10 to the power is 3. Next, this can be written as 10 to the power is 2 over this one. Right? So then, so 10 to the power is 3 into 2 into 2 is that is 4. Right? So here 10 as it is 10 to the power is 3 and 10 to the power is 2 into 2. So that is 10 to the power is 4. So then this is equal to 10. So this is 1, 3, 4. So that means 4 plus 3, 7, 7 plus 1 is 8. So from this one, 10 joule is equal to 10 to the power 8 earth. Okay, this is the method to convert one system of unit to another system of unit. Okay, so here, what is our given question here? The 10 joule, convert 10 joule into earth, right? So first we have to find out 10 joule, right? 10 joule means J indicates that that is a unit of energy and it indicates that the CGS unit of energy, right? So first we have to write the dimension formula for energy. Dimension formula for energy is m squared into the power is minus 2. So after that, so in this case we are converting SI system unit to CGS system unit. For that reason, we write the SI unit system and CGS system unit. So here already we know that the M1, L1, T1 value In SI system, mass is measured in terms of kg, length is measured in terms of meter, and time is measured in terms of second. So in CCS system, the M2 value measured in terms of gram, L2 value measured in terms of centimeter, T2 that is second, right? So after that, N1 value is they are given. N1 is equal to that is 10. So after that, we are going to find what is the ABC value. So to find out the ABC value, we are comparing the powers of this physical quantity with respect to the powers of that physical quantity, right? So while comparing this one, here m to the power is 1 is there, here m to the power is 8. So a is equal to 1. Then here l to the power is 2, and here l to the power is b. So then b is equal to 2, and b to the power is minus 2, and b to the power is c. So then c is equal to minus 2. So once we know all the values, substitute these all values in this equation, simplify it, we will get the final answer. So that is 10 joule is equal to 10 to the power 8 Farad, right? So one homework, try this one. Convert 1 joule into earth. Convert 1 joule into earth. So this is the homework.